Hello, bonjour, it's Laura here. In this video, I'm going to talk about what's going on in a precipitation reaction. And then we're going to practice writing equations for precipitation reactions. Okay, so the first thing we need to think about is what's happening when solutions of ionic compounds are mixed together. Because remember, when they're mixed together, that's when you've got a precipitation reaction happening. So I've got a picture of two beakers here. So to start with, both of these have a soluble salt in them. So that means they've got salt that's dissolved inside of them. So you can see in these pictures that we've got some ions floating around. Of course, this isn't what you would actually see. These would just look like clear liquids in the beakers. But for our purpose, we can actually draw these things and we can see what ions are floating around. So in the first beaker, we've poured some potassium chromate. Like maybe we had a spoonful of solid potassium chromate salt and then we poured it into this beaker, and then what we've got are some potassium ions floating around here, and then we've got some chromate ions floating around, and they've got charges on them. And then we do the same thing here. So we've got some barium nitrate. Maybe we had a spoon of that salt and then we poured it in, and then we ended up with these ions floating around. So we've got some barium floating around, some barium ions, and then we've got some nitrate ions floating around. So then what happens if we take those two beakers and then we pour them together so that they're all in one beaker? So we do that, all the ions now, they're all floating around. Okay, but when they're floating around, they're going to end up coming into contact with each other. And then remember, some salts are insoluble. So in this case, what we're actually having is the barium. When the barium ions float around and they come close enough to these chromate ions, they actually are going to form a solid together. Okay, so the potassium, when it floats around and runs into the nitrate, it doesn't form a solid. They don't form a solid, they're still soluble, but the barium and the chromate, if they come close enough, they're going to form a solid. And so that's going to be your insoluble salt. And so this little pile of yellow stuff at the bottom of this beaker at the end, that's the barium chlorate. So that's the kind of thing that's happening at the molecular level when you have a precipitation reaction. So of course we want to be able to write that in a equation as well. So let's look at that. We're going to use a different example here. And so far we've talked about one type of equation, and we've just called it a balanced chemical equation. Now we're actually going to be more specific. We're going to call it a molecular equation. So here we've got a molecular equation. So as always, we've got our arrow, we've got our reactants on the left, we've got our products on the right. So here we've got lead 2 nitrate, and it's aqueous, so it's floating around as ions. And then we've got sodium chloride. Again, they're floating around they're both in an aqueous solution, so they're both in water. And then what happens is the lead and the chloride come into contact with each other and they form a solid. All right, so then here we've still got sodium and nitrate floating around. Those are still just floating around. And that's why it says aqueous there. All right, so this is an interesting equation. This is the type that we've looked at so far. It's got lots of information. We know this is aqueous, we know this is a solid. Now we have a second type of equation, and that's called an ionic equation. And what this does is show all the ions, like all of the ionic compounds, as separated in their ions. So anytime you have an aqueous compound, what you can do is separate that out and see each one of the ions and what their charge is. All right, so this equation here, it's much longer, but it's actually the same information as the molecular equation. So basically we've taken the lead 2 nitrate and we've separated it into its two ions. So notice each of them now has a charge. So that's and it did over here as well. We just didn't explicitly say that in the equation. Now we're explicitly telling whoever's reading our equation what the charge is. So this is lead 2 or 2 plus charge, and then this is the nitrate, which has a negative 1 charge. And then there would be 2 of them here. Oh, I'm having troubles with my pen here. I apologize for that. Okay, so here we've got 2 of these nitrates. Now notice the 2 previously was written in the compound name. Now that 2 has become a coefficient. And then both of these ions are written as aqueous. Same goes with the sodium chloride. So now this is split into its 2 ions, and there's a coefficient in front of the NaCl, and that coefficient stays the same here. Because there aren't any subscripts in this compound, those coefficients are all that is written there. Now, this is the interesting part that you have to remember. If you have a solid, it stays as a solid. That solid's not going to split up into ions, of course, because it's a solid. It's not aqueous. It hasn't in the beaker split into ions. It's actually stayed together as a solid. So make sure if you've got a solid that in your molecular equation that you don't separate that into ions in your ionic equation. And then same thing with this one. It separates into its ions. All right, so this ionic equation is quite busy. It's got a lot going on. This is difficult for somebody to look at. So what we can actually do is cross out all of the ions that are present in the products and the reactants, and because they're actually not taking place in the reaction, like they're not actually ions that are forming a new compound as a solid, they're just floating around. We actually call them spectator ions. And what we can do is cross these out. So if I look through here, do I have a lead ions on both sides? And no, I don't. Do I have nitrate ions on both sides? Yes, I do. So I can cross these out. So I'll cross out the nitrates. Those are considered spectator ions. Do I have sodium ions on both sides? Yes, I do. So I'll cross those out. And then do I have chloride ions on both sides? No, I don't. I've got a chloride ion here, and chloride is part of the compound, so it's not an ion. Okay, so what I've done is cross those out, and then what I end up with is what's called the net ionic equation. And this is a more popular way to write a precipitation reaction equation. Is actually the net ionic, because it's a lot simpler. So if you look at this, this is really telling us what's going on, and it's the nitty-gritty of the reaction. So we've got the lead ion and the chloride ion. They're both floating around in the beaker. They come into contact with each other. They're close enough that they can actually form a solid, and they're not soluble anymore. So that's the S there. Okay, so that net ionic equation is much simpler to look at. All right, so those are the 3 types of equations, and you should be able to be given a sentence that describes a reaction and then be able to write the molecular equation all the way down to the net ionic equation. So you'll do a lot of practice with that. So here's just an example of one that's nice and simple. So here we've got some silver nitrate, and it's being mixed with sodium chloride. So here in this beaker you can see that, this test tube, we've got the chloride and we've got the sodium, and they're floating around in here. And then in this little dropper we've got the silver, and we've got the nitrate, and they're being dropped in. And then when they are dropped in, look at what happens. You've got a cloudy solid formed, and that cloudy solid is this lattice. And that lattice is made up of the chloride and the silver. Okay, so really only these green balls, that's the chloride, and then only the silver, so that this white ball here, those are the only ones that actually take part in the reaction. And so that's why this net ionic reaction is written like this. So we've got the silver plus the chloride, and then they're forming the silver chloride salt. So very nice, simple way to write a reaction or describe a reaction. So we can use those solubility rules that we talked about previously to predict whether a solid's going to form when we mix two ionic solutions, because we could mix two ionic solutions and nothing could happen. There might not be a solid that forms. So the way that you do that is first you write out all the different combinations of positive and negative ions that could happen in this solution, and then you look at your solubility rules to determine whether each possible salt would be soluble or insoluble. So let's go through some practice with that. So this is basically the same one that we just did, but now I'm going to show you how that would work if we had that in a question. So say we've got some silver nitrate and some sodium chloride, and they're mixed and a white solid forms. Write the ionic and the net ionic equations. So here's all of the ions that are in that reaction. So we split up the sodium nitrate, and we've split up the silver nitrate, and we've split up the sodium chloride. So then we write the combinations of the ions and determine if any of them are soluble. So this is how I do it. So I take the first compound and I write it at the top. So we've got, and these are the ions for both. So we've got the silver ion, and then we've got the nitrate ion. And then from the other compound, we've got the sodium ion, and then we've got the chloride ion. So make sure you write the correct charges when you're doing this. All right, so then we look at the different combinations. So we know that we're not going to have two positive ions mixing, so we know that is not going to make anything. And we also know that we're not going to have two negative ions making any compounds either. So I can just cross those both out. So we could have sodium and nitrate. Okay, so that could be a compound. And if I use the crossover rules there, that would be the formula for that compound. We wouldn't have to have any subscripts because they both have a positive or negative 1 charge. And then the other compound could be the silver chloride. Okay, so those are our possible compounds. And then what we want to do is figure out whether those would form solids or not. So then we need to look at our solubility rules. So I'll grab my solubility chart here, and we're going to look for anything about, first we'll look for anything about sodium and nitrate. So if you look at this, sodium is going to be soluble. And is there anything about nitrate there? I don't see anything, but that's fine, because with sodium, there's no exceptions. Okay, so that is going to be soluble, which means that doesn't mean a solid. So remember that, soluble. Now with the silver and the chloride, let's look again at our solubility chart. So here, it's insoluble if it contains silver, and chloride is soluble, but an exception is silver. Okay, so that means that this is going to be a solid. And that is actually what we saw in that slide before, that would be a solid. All right, so then we can write the ionic equation, including the solid. So that's what sorry, I've got my writing it right over the equation. But this is what our net ionic equation would look like with all of our ions. And then there's our solid, the silver chloride right here. So then what you want to do is cross out all of those spectator ions, and then you end up with your nice net ionic equation, which is just the silver and the chloride mixing to make the silver chloride. Okay, so that's how you'd use your solubility rules to figure out what the solid is. Well done, miigwech.